Welcome once more to our possible UTME question series. Today is for physics. So in today's video, I'm talking about conversion of a galvanometer to either an ammeter or a voltmeter. This is a question JAMB loves to set and ask students a lot on electricity. So please, you must know how to convert a galvanometer to either an ammeter or a voltmeter. Now, the first one is to convert a galvanometer to an ammeter from G to A. Now, you must note something. A low resistance shunt is connected in parallel to the galvanometer. So if you want to convert a galvanometer to an ammeter, you use what? A shunt. And this shunt is what? Is a low resistance shunt. Please note, low resistance shunt. You connect it what? In parallel, not in series. In parallel to what? To the galvanometer. And this is formula for it. Your RS is equal to what? IGRG over I minus IG. I'll give you the parameters of this formula. Your RS is your shunt in the resistance. Your IG is the current in the galvanometer. Your RG is the galvanometer resistance or the resistance in the galvanometer, anyone. Your I is your normal or B current. Now, this formula, you must know it. It's an important formula you have to know. It deals with what? Conversion of what? Of a galvanometer to an ammeter. So your RS is equal to what? IGRG over what? I minus IG. Your RS is what? From the parameter RS is what? The shunt resistance. So is the resistance in the shunt. Your IG, this G, is what? Is the current. I know I is the current. So current in the what? In the galvanometer. RG. R is what? Is the resistance. So resistance what? In the galvanometer. Your normal I that has no subscript is your normal current. Your IG is what? Your IG is your current in the galvanometer. Very, very important. Now, the second one is to convert a galvanometer to a voltmeter. I've explained how you can convert it to an ammeter. This is what? To a voltmeter from G to V. Now, you know, for an ammeter, use what? A low resistance shunt connected what? In parallel. Now, for voltmeter is the opposite. A high resistance multiplier. It's called a multiplier. I what? High resistance. Now, it's connected what? In series to the galvanometer. So, if you want to change a galvanometer to a voltmeter, rather, you use what? A high resistance multiplier, and you will connect it what? In series what? To the galvanometer. Very important. Now, this one you need to know to change this unit. R is equal to what? V over I minus RG. Very, very easy. Let's take some past UTME question. Now, the first question they ask, in order to convert a galvanometer to an ammeter, you use what? From G to A. They're asking this question. From G to A, what do you use? A low resistance what? Shunt connected in what? In parallel. Option what? Option A. Very, very straightforward. A low what? Resistance shunt connected what? In parallel to convert what? Your G to A. Your galvanometer to an ammeter. Very straightforward. So the rest options are what? They are wrong. Now the next question, I'm going to attempt it. Now this is a calculation question on either this or this. I'm going to break it down now very soon. So this second question, you were asked a question on this aspect I just taught you right now. Now they said a galvanometer has a resistance of 5 ohms by using a shunt. Once you see shunt, know that you are using what? Dealing with this from this particular example from G to A. But if you hear multiplier, you're using what? This formula. So by using a shunt of a resistance, the galvanometer could be converted to an ammeter. They have told you already. But once you've seen this shunt, they don't need to tell you to an ammeter. Automatically, you're meant to know that you are changing to an ammeter, of course. So could be converted to an ammeter capable of reading 2 ampere. What is the current through the galvanometer, which is what? Your IG. Current in the galvanometer, IG. Now, using this formula, R is equal to what? IG RG minus, all over I minus IG. Now, a galvanometer has a resistance of 5 ohms. So, the RG is what? 5 ohms. That's the resistance what? In the galvanometer, this RG, 5 ohms. Now, by using a shunt wire of resistance, so this is the what? Resistance in the shunt, RS, 0.05 ohms. Write it down. So, we have written the first parameter, second parameter. Now, let's go on. The galvanometer could be converted to an ammeter capable of reading 2 ampere. This is your normal current. The normal current given. Now, what is the current in the what? What is current through the galvanometer, which is what? Your IG. Your IG is what? Unknown. Okay, so using my formula, R is equal to what? IG RG over I minus IG. You have to now substitute the values. Your RS is what? Is 0.05. IG is your unknown. You are looking for it times what? Your RG is what? 5 ohms. You get over 2. 2 is your normal current. How are you saying it? Minus Now Ig is still your unknown. So once you cross multiply, this is just normal mathematics. Once you cross multiply 0.05, we'll go and multiply this to here. You get, so that's this. Then it's equal to what? Ig times 5 is what? 5 Ig. Okay, so opening the bracket, this times is what? 0.1 minus 0.05 Ig. So once you collect like terms, 0.1 is equal to what? 5 Ig plus 0.05 Ig. So once you add it together, 0.1 is equal to what? 5.05 Ig. So once you divide both sides by 5.0 to make Ig stand alone, because that's your unknown, of course. So you have 0.1 over what? 5.05. So your Ig is equal to what? 0.01980 ampere. Now, you have to be very, very careful. Look at your options now. After getting this, are you seeing anything similar to it? No. Now you have to now apply your normal normal mathematical reasoning. Do you get? Now looking at this option, 19.8 times 10 to the power minus 3 ampere. You know, if you basically expand this 0.0198 standard form, you move it to what? 1, 2, 3. So it's 19.8 times 10 to the power minus 3 ampere. Now please note, in physics, 10 to the power minus 3 is called milli. I believe you know some terminologies. We have micro, we have milli, we have nano. So some basic numbers in physics. So 10 to the power minus 3 means what? Milli. Milli. So you can just say the answer is what? 19.8 milliampere. This milli is still what? Times 10 to the power minus 3. Now, the closest answer to it is what? Option C. Because 19.8 is approximately 20. So you can say it's still approximately what? 20 what? Milliampere. So making option C the answer. So if you get a lot from this video, do also share it to your friends and anyone you know that writing this year's UTME. I'll see you in my next clip.